there, Internet. So last time we were following a gentleman by the name of Jeff Crocker. Croker? Not sure how to say that. He was the guy that inspired me to create the simulator for the gear cutting shaper simulator thingamajig. And more recently, because Jeff and I both had a question about how to calculate the flat on the cutter, I've discovered this brilliant gentleman here, Andy. He's been doing this kind of stuff for a long time, and he's got an amazing channel. You should definitely check that out. But I believe it was this video? I'm not sure. I think it was this particular video here where Andy shines a light on the calculation required to do the tip calculation.
Minus these two.
So right about here is where we get the information that we need. So around the 4-minute mark of the video, he jumps into a whole bunch of the different parameters that are interesting. I think actually
Exactly half. If that didn't make any sense, the equation is...
Yeah, so yeah, we're back to this kind of math. But anyway, I deciphered this diagram. Actually, it was in a different video, but there's a little bit of trigonometry that you can do to calculate. You know what this angle is, and you can calculate this distance, and you multiply that by 2, and through the magic of math, you get the right answer for the tip width. Yesterday, Andy released a wonderful video on making pretty gigantic gears with just using a slitting saw. And this, if you think about it, is very similar to what we've been looking at as far as the kind of modified shaper technique on a CNC machine. This is a great video. Check this out. This methodology is very similar. This is a manual method, but you could use the slitting saw technique, or you could use a V-type cutter. Now that I have my new calculation, and you're able to actually use my simulator tool, and it automatically calculates a whole bunch of the stuff that it didn't do before. So if I go in here and I want to change the module, let's say I want to make a module 4 gear with let's say 27 teeth. I hit the old Renderino button, and there we are. There's a single tooth that's simulated cuts. The steppiness of the cut is driven by this parameter, steps. And it's somewhat driven by another parameter, which is the travel distance for the tool, which is just about the pitch diameter. So the other thing that you can do here is easily change the pressure angle. So if you want to go to 14.5, you don't need to hit enter. This is all the G code that's getting generated, unnecessary at this point. But here is a 14.5 pressure angle. I have as a quick refresher, if you click on this or you select it over here in the GQ models dialog, you can then go up to tools and export as STL. You can then import that into Fusion 360 and compare it against a generated gear. So that's what I've done here. So this gear has all the same parameters. What I've noticed in this gear generation is obviously the tooth hole, my technical term here again, the tooth hole is much bigger, but that's due to the tool geometry more than anything else. The depth that we set the tooth hole, the cutting depth that we set in our simulator and in the real world is going to be one of the things that drives exactly how closely we get to this geometry, this flank geometry. This is the most important part. This is where the contact surfaces should be orthogonal, I believe. Anyway, you can see we're really close here. So it's really between this point, and I'll try to measure it. Let's see if I can do it. This and this. So that's like a, that's like a tenth of a hair or something. So really small. So the way that you tweak this is right now, unfortunately, there's a variable in here called clearance, and that gets multiplied by the tooth height. Now, the tooth height is 2.4 times the gear module if the gear module is larger than 1.25, and it's 2.25 times the gear module if the gear module is smaller than 1.25. I don't think this making it 110% and larger for clearance is necessarily the right thing. But if I leave this at 0 or at 1, where it doesn't modify the tooth height, what we end up with is a larger, we end up with a slightly larger tooth. So you can see on this one that was generated without the same amount of clearance, we have a considerable amount more width in our tooth, and so that'll definitely affect all the aspects of the gear. Whereas here, we've roughly halved that. So it's not without its problems. It still requires a little bit of manual tweaking. This is the tool that's used for the Boolean subtraction to make the cuts. This length here is automatically calculated based on Andy's helpful equations, and that was really guesswork before. So that's pretty good that that's no longer the case. Really, the main guesswork at this point is the depth. If you can imagine this traveling in parallel with this green line, so the tool's going to travel in parallel with that green line. The depth is from the edge here into the part, and then it translates it down here. But the depth is, the deeper you go, because this is wedge shaped, the deeper you go, the smaller your tooth ends up. Even if you have the perfect length on your tip, if you're not deep enough, you won't have the right shaped tooth, and you won't have enough clearance for your gear teeth when they mesh. So again, the fiddly bit right now is this clearance number. What I may do, and please let me know in the comments below if you can help. What I may do is I may attempt to find a library to render the gear based on, we have all the gear parameters in here already. So if we could render a vectorized version of a perfect gear right in this program, and then you can very quickly look at it and see comparatively what the simulation produces versus the perfect gear. You can kind of skip this whole step of putting it into Fusion 360. So the other thing I'll just ask people, if you're a decent Python programmer and you want to contribute, that would be super helpful. So in order to make that easier, and in order to make it easier to collaborate with you, last time I put the code into a GitHub gist. I've created a repository this time. So if you want to create a pull request, the file that gets loaded into CQ Editor is this virtual shaper beta1.py. And this is exactly the same as you can see in the editor over here on the left. So those two files are the same exact text. Yeah, if you could figure out a way to get this CAD query renderer to do that vector gear based on, I think we have all the parameters that we need, that would be super helpful. So just create a pull request if you want to. If you know how to do it and can just tell me the best way and easiest way to do it, and you don't want to do the work, just ping me in this down in the comments below, or create an issue on GitHub and let me know the right way to do this. So that's it. That's my quick update. I haven't tested it on the old CNC machine just quite yet. There's really no changes to the G-code generation. I've just organized it a little bit with as far as the editable, what I think are the most likely editable parameters, and the stuff that's probably shouldn't be edited. It's pretty straightforward. If you have any questions, leave them down below. Thanks for watching.